This is an NMRA-PCR Coast Division eClinic by Dennis Drury on how to use Raspberry Pis to implement JMRI for a combination of Decoder Pro, layout control, as well as CMRI.
This is a clinic that I gave at the Return to the Redwoods convention earlier this year. And it's basically how to set up JMRI on a Raspberry Pi. And a Raspberry Pi is a standalone microcomputer, very cheap, easy to use. And the slide is out of date. I don't think it's $35 anymore. I think it's a bit more than that, but let's see. Okay, so what is JMRI? I don't know if everybody in the Silicon Valley knows this, but I'm sure you do. JMRI is the Java Model Railroad Interface. It's a suite of applications running in a single program, which includes Decoder Pro, Panel Pro, Operations Pro. You can interface cell phones and tablets so they can be used as throttles and other things. Many other features, too numerous to mention here. And it is open source and free to download and use, although donations are encouraged. So, what is a Raspberry Pi? A Raspberry Pi is an inexpensive, fully functional microcomputer that can be set up and configured to run JMRI. So you don't need a full-blown computer, an expensive laptop, or anything else. The Raspberry Pi will support multiple devices. You can interface a keyboard, 2 monitors, a mouse, and other hardware to interface to your layout. Then where can you buy a Raspberry Pi? Well, where can you buy anything these days? At Amazon. So this is where I got mine. This is the Amazon window for a Raspberry Pi starter kit. And this says $119.99. The price has gone up like everything else. I looked this morning, it's $139, and they are in stock, so you can get them. I like this because it comes with everything you need. It comes with the case, the SD card reader, a fan, a power supply, cabling, and pretty much everything you need to get started. The only thing you would need to add is a monitor and a keyboard mouse. And any questions in the meantime, feel free to jump in. This is my Raspberry Pi JMRI setup for my railroad. I have developed a CTC panel based on a USNS CTC system. And you can see I have staging on the lower level staging, upper level staging, 3 sidings in the middle, some industries. There's a yard in here. But the important thing is this is the Raspberry Pi right here. This is a Digitrax UT4 throttle for size comparison. I have a Sprague connected to the Raspberry Pi, which I use to program my decoders with Decoder Pro. I also have a PR3 to connect into my Digitrax system to monitor the LocoNet. And it's not visible in this picture, but there is also a CMRI interface, which I'll get to in a second. So that deals with the hardware. Now what about software? Part of the beginning of this clinic, I said, you don't need to be a software guru to know how to set this up. And here's why. I don't know how easy this is to read, but there is a gentleman out in the world called Steve Todd who has written the software for the Raspberry Pi. It includes the setup for the Raspberry Pi. It includes JMRI. It includes, basically, you download his file, you copy it over to the SD card, you put it in the Raspberry Pi, boot it up, and it works. It's just pretty much that simple. It's hard to read, but if anybody needs it, they can email me. My email address is at the end of the presentation, and I can send you the link for Steve Todd's website. So when you get the program loaded on the SD card and you turn on your Raspberry Pi, this is what you get. You get the JMRI start screen. you get Panel Pro, and it automatically defaults into Panel Pro. And I'll point out that from Panel Pro, you can also bring up your roster and your locomotives and do your programming that way. So it comes up and it opens up, in my case, 4 windows. The regular Panel Pro window. It opens up my file for my railroad, the Klamath Falls subdivision. LocoNet over TCP, which I don't really use, but it opens it up anyway. And the weed throttle window here, which I'll get to in a second. Next thing that's important to know is if you pull the USB ports right here when you're setting up, this is kind of important, and I know it's hard to read, but this is all of the ports that the Raspberry Pi has. And as I said, I have 3 connections to each one. Well, as an example, if you plug in your CMRI node, you'll see one of these ports activate. And if you unplug it, you'll see it deactivate. And that tells you that this port right here is the one to show that.
Dennis?
This is my, yes.
Just
I'm
let
here.
you know if you can see chat, some questions are coming up for you there, sir.
Ah, okay, yeah, I see 5. So, okay,
Ken Adams.
looking for the Coast Flyer. I try to show my screens as a full screen. If I started it on my computer, then I couldn't do the share screen. So, oh, and somebody put the Todd link up. That's good. Thank you.
Go ahead. Try putting a slideshow right now, Dennis. Throw it in the slideshow. Go up where it says slideshow, up at the top.
Okay. Yeah, I'm working on it. Let's see. Slideshow. Hey,
Yeah. There you go.
What do you know? Okay, thanks. Okay. So let me go back to the previous screen for a second. So here's my USB ports. You can see them listed here. So the next screen, this is my CMRI configuration. And you can see the serial port is the TTY USB 0. And the reason I knew that is that as I unplug the connection to the CMRI, this TTY USB 0 would go away. Then when I plug it back in, it would come back. And that's how you're able to determine which port is used for which hardware configuration. So this is my CMRI connection. Again, I have a LocoNet through PR3. I have a Sprague programmer. All of these have a USB port for the Raspberry Pi. This is my CTC screen for my railroad. This is running on a simulator basis right now. I pulled this off my computer, but lower level staging with the selections for the in and out. Klamath Falls crossover, here's the main yard, and the Klamath Falls siding with the depot. Working its way up, this is the climb to the third level actually. Third level and on into upper level staging. As of right now, the railroad is only built to right here, but I've got the panel ready to go for when I finish this all up. This is my CMRI connection. This dongle here, this cable goes back to the Raspberry Pi. Excuse me. And then it talks to what I'm using the CP node from Seth Newman's company. I have a node here. I've got 3 others. Is that right? 1, 2, 4 others at this point in time. And the CMRI talks to each node in turn. Seth's company has model railroad control systems, has really good documentation on how to set up the individual nodes. All of that documentation is downloaded from his website. If somebody wants to put modelrailroadcontrolsystems.com into the chat, that would be great. But again, setting up these nodes, you have to set up the configuration for each node. You have to configure it in JMRI and you have to configure it in the board itself. So this is configuring the board itself. Basically, you set an individual address for the board, the speed it's going to talk to the system, and these are extender boards that are available. So let's see, 1 is input, so I have 1, 2, 3, 4 inputs and 1, 2, 3, 4 outputs, and these I'm not using because it says not assigned. More chat, let's see. Thanks for that. Okay. Why didn't it go down? Here we go. So again, this is from Seth's documentation. The master host computer, this is the Raspberry Pi. You need the RS-485 card, which is this device right here. And then you go into the first CP node, which is what I'm using. The S-Mini and the SUSIC are both left over from Bruce Chubb's original CMRI system, but you feed in a serial mode from node to node to node. And like I say, I have 4, so I have 1 more over here that I have set up. You have to, in JMRI itself, you have to set up the CP nodes. Again, this is from my railroad, so node 11, node 12, node 13, and then I also have a node 10 in here, which is not on this slideshow. I set it up as CP node, the node address. This is pretty much you don't need to worry about. And these are for the extender cards, the extender boards that Seth offers. Once you have that configured, you click on update node, it goes into here. And here you can see node 11 has 32 input bits, 24 outputs. And the bits are basically to track occupancy detection, turnout position. The output bits are to send a signal to throw the turnouts and to set the signals for the correct aspect. Hang on, I'm going to mute for a second. Maybe. Excuse me. Once everything is set up, you want to check and you can poll the CMRI system. That's Selection in Panel Pro. Here you can see that polling 11, receiving 11, polling 12, receiving 12, polling 13, receiving 13. And it just repeats over and over again. As things change on the railroad, these values here will change. So that's not really important. This is just a check to see that it's actually working the way you expect it to. So what else can JMRI do? I'm sure everybody knows most of this, but yeah, how much time do we have? Decoder Pro, these are the locomotives I currently have on my railroad with the decoder models, the road name, road number, manufacturer, model, and everything else. This was all done through the SPROG to program these up, and they are, I think pretty much every one of these is on the RIS Pro. These are the trains that once my road is complete, I will be running, but I can also set this up as a simulator to verify traffic patterns and to make sure that the trains run as expected. I have done this in simulator mode several times, and it seems like it's going to work. And I think that's it. So, questions? So is everybody awake?
I have a question, sir.
Sure.
So my wife has a little laptop, right? What advantage of, instead of using that, what advantage does using the little Raspberry Pi have over just taking some leftover computer or laptop?
That is one option. Some people do have leftover computers or laptop or alternative than using your regular computer. At one point, I had my regular laptop configured to the railroad, and I thought, yeah, I keep taking it other places, and I just thought, for 119 bucks, I can just buy this. It's already installed, it's already in place, and it's ready to go. So again, it's not necessary, but it's, if you don't want to use a regular computer or dedicate one to the layout, then this is one way to go.
Right. I have noted that her little laptop is a Windows machine, and keeping the stupid thing updated is a nightmare. How often do you have to how often do you have to update your Raspberry Pi to keep up with whatever?
Sure. Well, first off, my Raspberry Pi is not connected to the outside internet, so it's only its own little local network. I don't have a network connection to the World Wide Web for it, so it doesn't automatically update. I have not updated it since I installed it. The only reason I could think of to update it is if right now that Pi is running JMRI version 4.20, and if I wanted to go to 4.26 or 5. Whatever the latest version is, I would basically just go to Steve Todd's website, download another image, and reload it. It's pretty much that simple. I don't know if anybody can see this. This is, see if I can put it up here where you can see it. This is my railroad on a Samsung tablet, which is connected to the Raspberry Pi. I can throw switches from this tablet. It's basically if I was sitting in front of the Raspberry Pi computer as well. I also have engine driver on here, which that is one of my locomotives. It's set up if I just start increasing the speed, it'll start moving. So I'm not going to do that. I have my iPhone 6 connected to the Pi if I want to use it for throttle. I usually don't because I have enough throttles for myself, but if other people want to come over and they bring a phone or a tablet, it takes 2 minutes to connect them up and they're ready to go and they can start running trains.
Is the Raspberry Pi providing a wireless connection?
Yeah, it comes with it.
Oh,
And
okay.
Steve Todd's image turns it on when JMRI boots up.
Okay.
Yeah, so we actually in Pleasanton at the club in Pleasanton on the O-scale railroad, we put a Raspberry Pi in under the railroad to run JMRI just to have a wireless connection for basically control.
Yeah.
And it turns out pretty inexpensive if you don't have to buy the full starter kit. I think they're about $45 to $50 to buy a Raspberry Pi and put it in.
Right, and then you need the power supply and all the other. So I just bought the kit. It was easier that way.
Stuff. Yep.
Right. The other thing I will point out is I ran into a problem with my engine driver and wheat throttles a while back, and it turns out that when the Apple updates the iOS on the iPhone, it can sometimes require you to reinstall the wheat throttle, and the same with engine drivers. So if it's not working, that's the first thing to check is the tablet or the phone.
Is there a minimum version of Raspberry Pi required? Can you use an old 3 or old B?
I had, before I bought the 4, I had this same setup running on a Raspberry Pi 2, and it worked just fine.
Great.
So if you can find one of those, and they're probably cheaper, that will also work. JMRI doesn't take a lot of horsepower, if you will, so you don't need a lot of RAM. You don't need, I think you need at least an 8 gigabyte SD card, but it just seems to work. I still have the Raspberry Pi 2 in case I ever need a spare, but it's working just fine.
So unless you're short of time,
I'm not short of time.
David or Phil, and I might have missed like it was like a block diagram between the Pi and the hardware that Seth makes and the actual turnout motors, Sprague, and all that. Was there a block diagram for that?
Yeah, let me start sharing again, and we'll go back to that. Okay, so let me back up. Hopefully. Oops. There. Okay, that was part of it. Okay, so let me put my glasses back on so I can see. So this is the RS-45 interface right here to the Pi, to the first CP node, and this is the first one. Here's the second one going out. Here's a tortoise. This is staging, so I didn't feel the need to put my tortoises underneath. They're just mounted right next to the turnout they control. This board here is also from Seth's company. It's called an RSMC, remote stall motor controller. These wires go back. Two of them are power, plus 12 and ground. And then the green wire goes back underneath here to one of these pins. So when I select a route through the Raspberry Pi, if this turnout is part of that route, this bit will throw and it will the turnouts themselves. And this is a basic block diagram. This master host computer is the Raspberry Pi. The USB 485 card, that was that little blue box I showed you. There's really, each one of these is a pair. So 4 wires going to the first CP node, which was in the picture I just showed you. And then coming out, there were a cable coming out and going to the next node, which is about 15 feet away. And then it comes out, and the last one is out here. It's actually in a temporary position until I get the loop up to the 3rd level put in, where it's going to live underneath that. Is that clear?
Yeah.
Okay.
Yeah. Yeah, thank you.
Dennis, I think the thing that's important is that 485 bus, it's basically.
So anything else?
Dennis, just the comment, the 485 bus is a daisy chain. So it goes from one node to the next, and it's a poled bus. And it's the same whether you're using Seth's products. Physically, it's the same interfaces whether you're using Seth's products or the original CMRI stuff from Chubb.
That is correct. That's why, and again, this is Seth's documentation. So the S-Mini and the SUSIC are here because you can still use the old hardware.
Right.
That's great.
So
and you need a similar card from USB. For example, if you want to go to an NCE system on your DCC, you need a similar serial converter that goes to that connection. So it's a different kind of connector, but it is the same thing.
Right.
From USB.
So like I said, here's the Pi, and this cable here, the white one, goes to the Sprague, which then connects up to the programming track. Yep. This silver connector is the one that goes over to the RS485 connection to the CMRI system. And then one of these ones underneath, I think it's this gray one, loops around and connects into the PR3 to interface with my DigiTrack system. And oh, oops, I went too far. Like I said, here's the LocoNet connection and the Sprague programmer connection. And the advantage of Steve Todd's image is you download it, you write it to the SD card, you put the SD card in the Pi, you apply power, and it just boots up into JMRI, and off you go.
Yeah, I think that's an important point, Dennis, to make, is that programming and using a Raspberry Pi is a little different than a traditional computer where you're actually doing all the work on the computer. You basically develop an image on a computer, put it on a micro SD card, plug it into the Raspberry Pi and run the Raspberry Pi, and then it has the image.
Right.
So you're actually using almost the Raspberry Pi as not as a computer, but as a control node, so to speak, that's got all the programs built into it that it needs.
Yeah, it's called a microcontroller. And again, the only programming knowledge you need is JMRI itself. You don't need to know any Linux or Unix or any of that unless you want to dig into it. I mean, you could, but again, you put the image on the SD card, you plug it in, you turn it on, and this is, oops, it boots to here. From here, you can get into Panel Pro. And like I said, once you get into Panel Pro, you can go anywhere.
And Dennis, whose card was that?
The
whose image was that?
That's Steve Todd's, and that
Todd.
link is in the chat.
Okay, thanks.
Yeah, I think the other question that was asked about the level of Raspberry Pi, one of the things I think is cool about this is you can use it as a programming station on your Workbench really easily and have a track built into your Workbench where you can program, have the Raspberry Pi there, may have an old small monitor there and keyboard to work with or something like that. And for that, I think you probably could use one of the older Raspberry Pis pretty easily.
You
If
can.
all you're doing is you're not running Panel Pro, which is I think more application intense than just running the programmer, the DCC programmer panel.
Mm-hmm. Right, but what I'm saying is this is my workstation, if you will. So off to the side here, well, there's the Sprague, and the programming track is right over here next to staging. So, and as I said, this did all run on a Raspberry Pi 2. The one thing I will point out is that Steve Todd's image does not include a link to Decoder Pro, but if you just click on Panel Pro, you can then get to your roster. That's not a problem. And the other thing I'll point out is that I do, let's see, let me go back. Oh, nope, I want to go forward. Sorry. So this Panel Pro panel, my CTC system, was developed on I do it on my laptop in a simulator mode. And then when I'm ready, I just copy the file to a USB card, take it to the Raspberry Pi and put it into this folder right here where it says open JMRI user files. Just double click on that. It brings up the user file folder. And then I just copy from the USB into that folder and set the system to boot into opening that file, and we're all set to go.
Hey, Dennis, just out of curiosity, I saw Todd had an email for support. Are there any online support groups like on groups.io for this that people can use if they start going down this path and need some technical support?
Yes, I will say that Steve Todd is on the JMRI users group on groups.io.
Yep.
When I had problems with my tablet and my phone trying to connect up the engine driver and the Wii throttle, that's where I went. Steve Todd got right back to me, and we figured it out within 24 hours. Through JMRI, sometimes they'll take it offline. But yes, the support is there. And like I said, I put my email at the end of the presentation.
That's great, Dennis. Thank
So
you so
people
much.
can email me grammar, but I can try.
Thank you, Dennis. That was great.
Thank you.
Any other questions for Dennis?
I just put my email in the chat.
Ah, super. I was going to do that. Thank you. I think it's a great, I think the thing about Raspberry Pi is it's a great way to get that control for fairly reasonable cost and not having all the complexity of a laptop or a desktop there. And plus it's tiny. And like I said, if your Workbench and that is in a separate room, my Workbench and my layout stuff are.
Sorry.
Well, go ahead.
Yeah, and people mentioned a Windows update. I've seen Windows update on a laptop or whatever cause it not to talk to the railroad anymore. And again, because the Raspberry Pi doesn't do that, you are in control of any updates you want to do. It's just going to sit there and run whatever program is in there with no updates.
And the beauty of it is from a control perspective, like you said, the control panel that you've got there is generated out of Panel Pro once you built your configuration structure in Panel Pro.
That's correct. And I see a question from Ken Adams, moving to loco-fi Wi-Fi command communication with locomotives with no signals on the track. If we're talking about what's called dead rail, I don't know if this is relevant or not, Ken. I haven't really gone down that path, so I can't say it is, but who knows?
Well, I think it's important to there are kind of almost three use cases here that Dennis, you've talked about simultaneously. The first is the programming track, which is kind of a dedicated use of the Decoder Pro and that to program your locomotives. The second is the ability to control DCC, which is on the layout directly from JMRI, which lets you use, the Wi-Fi throttles and that kind of thing. And then the third part of this is the whole thing of doing the CMRI for signaling and turnout control and layout control. And I think even if you're using dead rail probably changes the first two, unless you're doing dead rail with the DCC decoders, where you want to use it for the programming of the DCC of the decoders. But if you're using something that doesn't have DCC, that's a separate dead rail system, it still has the advantage of being able to do signaling and turnout control and those kinds of things as a separate way to control the layout.
Yeah, that is correct, Phil. And my prototype is CTC. So since my prototype used it, I have to use it. I based my panel on a prototype panel that controlled the Cascade sub from Eugene to Crescent Lake. And so again, you don't have to use the Pi for programming decoders. You don't have to use it for DCC communication, but you can use it still for signaling and turnout control. You look
thanks,
pensive,
Dennis.
David. Thank you, Phil.
Thank you, guys. Thank you, Dennis. Thanks. I think it's great input, and great way for folks to think about if this is the right way to proceed with some computer integration and control. So everybody, a round of applause for Dennis. Thanks.
Thank you. And again, remember, it's cheap, and JMRI is free to download. Donations are encouraged.
Yeah, I never got an answer to what programming language is used on JMRI. Is it Linux or?
JMRI is Java program using the Java language, and using Java
What
means
code is it written in?
Java. The program itself is written in Java for JMRI. The Raspberry Pi operating system is Linux.
Yeah.
But Raspberry Pi, you can also get images that will run Windows 10. I have not used them, but I know they're out there. But,
and Ken, Raspberry Pi also uses Python.
Okay.
So JMRI is built in Java. That's why it's Java.
Is it basically
it's
a JavaScript app?
It's a Java app. It's not JavaScript. It's Java. Java and JavaScript is a subset, but it's Java running on a Linux, i.e. a Unix computer.
Okay.
But if you buy a Raspberry Pi and you want to write your own program, you can write programs in Python. So, for example, at the club in Pleasanton, we set up a couple of basically their sound stations where you push a button on the wall. We've got a directed antenna, a directed sound speaker system above. It's kind of a cone speaker system, and it plays a specific sound. It's not a sound file, and that's just done using a Raspberry Pi in Python, where it's a pretty simple Python program. When you push the button, it plays a sound file, and there's actually a button that you can stop the play in that. And that program is written in Python and loaded the same way down into Raspberry Pi. So JMRI is one way you can use it. The kind of standard programming language is Python.
I'd really have to go way back to dust off my old Java.
Ken, just as a follow-up, JMRI is an acronym for Java Model Railroad Interface. That kind of explains it.
Yep.
But because it's written in Java, it can run on a Mac, it can run on Windows, and it can run on the Unix system.
Railroading's presentation, good idea, right?
What was that?
I'm just listening about railroad presentation for Bakersfield area, for the Fresno area.
So anyway, to follow up with Ken, if you download the JMRI program from the JMRI, they have the 3 different operating systems to choose from. And as I said, I've developed my panel on my laptop, which is running Windows 10, and then I can transfer the file over to the Raspberry Pi. Does that answer your question, Ken?
Yeah, it sort of does, but yeah, I'm not really interested in getting into it, but I'm just curious as to what the foundations are.
Sure.